I'm Pharo. I'm a PhD student at the University of Brest, France. And I will talk about dynamic round-trip engineering in the context of FOMDD. So, FOMDD is for feature-oriented model-driven development. It's composed by feature modeling. It's composed by feature modeling. Feature modeling is about breaking down software systems in terms of the features they provide. It is used to define a family of related software and can be shown like a tree of logical features that can be implemented using piece of code. From a feature model, you can define multiple configurations. Configuration is just a selection of features, can be shown like a selection of features. And from a configuration, you can weave together a piece of code and to produce the final software. Model-driven development is about building abstract representation of software systems. For example, to describe a complex software, you can split it in multiple simplified representations, and you can compose this piece of model together to represent the whole system. So in fact, FOMDD is the blend of these two approaches. In FOMDD, we use model to implement features, and we use configuration to weave model together to represent a specific software in the software family. And from this world view of the system, you can, for example, use model transformation to generate code. Why we use FOMDD? We use FOMDD in the context of the cross-fabric project. The cross-fabric project aims to help developers to prototype and assess multi-platform software. And one of the key ideas behind cross-fabric is to use simulation of the software in the development environment for validation purposes. And obviously, it's implemented using Pharo. How we use FOMDD in cross-fabric? We implement features using instances of imorph-like meta-model. Something like that. You can define class, attributes, method. You can link together these kind of elements, and this element can be attached to feature. One more important thing is that method can have a body defined using IST nodes. So from our feature model, you can define configuration. We use configuration to describe a text form specific software. And from these configurations, we can select four meta entities attached to the feature model with this meta entity together to produce Pharo code for validation purposes. So in this context, what about RTE? RTE for round-trip engineering is about synchronizing the same information is multiple artifacts that can be at several levels of abstraction. So why do we need RTE in cross-fabric? We need RTE to let developers investigate solutions from any place, from the model side or from the Pharo code side. In fact, we want to let developers, for example, to investigate some solution at a high level of abstractions, or sometimes developers need to just change some implementation details in the code. And we want the developer investigate this kind of solution at both sides without having to worry about inconsistency between our model and the implementation, and without having to start or restart anything during, for example, a simulation. So, in fact, the RTD takes place between our meta-entities and our generated Pharo classes. What is the problem in this process? The main problem is that we have to manage a one-to-many relationship between one meta-entity we are described here and different implementation we can define using configurations. For example, you can have here a class, and here you can generate, for example, two implementations of this class with different attributes and different methods. Or we can synchronize implementation with this class in this context. One of the problems caused by due to this one-to-many relationship is the duplication of the information. More you have duplications in your run-through process, more the run-through process will be hard to implement because you have many information to synchronize at different places. So we have to avoid model about duplication, and we have to take care about dependency. For example, during the reverse engineering, when you update something from a generated class here, you have first to reflect this change on the model, on the related model, but then you have to synchronize other configurations that use this meta-entity. And, for example, when you add a method at the implementation side, you have to take care about dependency with features. This method has to be attached to a feature. And what is this feature? So, just a quick overview of the proposed solution. We use custom Pharo classes. We use Pharo classes as executable containers for models to avoid duplication. So, in fact, when we generate Pharo classes, we just use Pharo classes to hold data and to delegate behavior to model. Just an example, technically we use slot and method proxy to do that. As you can see here, for example, a method proxy will just retrieve the IST from this relative model and execute it on the current instance. So there is no duplication of code. A Pharo class, a generated Pharo class, does not contain any code. It just delegates all to the model. Now, just an overview of the complete approach in the root tree, how to make working together the forward engineering and the reverse engineering. To do that, we introduce a mediator object, an object between model side and implementation side that have to ensure the consistency between the two sides. It's named change manager. If I start from the reverse engineering, in fact, we install the change manager for each generated class. We use the change manager for each generated class instead of the Pharo class installer. In fact, the change manager takes all the control of structural change on the generated class. So when you change something, for example, in a class, in a generated class, the class just asks the change manager, just delegates, just forwards this change to the change manager. There is no actual change. The class cannot change itself. The change manager can ask the developer to resolve conflicts. For example, when you add methods in a class, in a generated class, the change manager can ask the developer what is the related feature for the new method. When conflicts are resolved, the change manager can actually update models. So, for example, if the method is updated, it updates the method body, can add a method in a new model. And when a model is updated, it fires events that can be listened by the change manager. And when the change manager, when model is updated, the change manager will listen event and can update the generated class. For example, if a class are updated, the change manager will find the generated class in the one-to-many relationship and update it if it is needed. To summarize, we use dynamic round-trip engineering in the context of FOMDD. In the cross-fabric project that aim to help developers to build and to access and to prototype multi-platform software, and our goal to let developers investigate solutions from any place without having to stop or restart anything during the development process. And we implemented that using Pharo classes as executable containers for models, and we used a mediator object that manage the consistency of the change and that manage the one-to-many relationship between objects, between models and implementations. Thank you. If you have questions.
Do we need for questions?
Did you try on a bigger example if it works and if it's scaled?
Not really on bigger example. On small example, yes, but not on bigger example.
And do you think that there's something that may make that it doesn't scale?
Yes, because in fact during simulation, the performance at execution time is not really a problem because you have time for compilation because you are using Smalltalk, you just reference objects. So it is you can directly execute what you do. You are in the model, you can launch a simulation. You can, oh, I have a bug on my simulation. I can just open an inspector on my simulation, debug it, change the code is synchronized with your model, and you can restart from your model at the point you was. So I think I don't have a performance problem.
You talked about asking to the developer, to the engineer, to solve the conflicts. Can you quantify how many conflicts do you have? I mean, if it's 5,000 conflicts, you can't ask the developer to solve that much conflict.
Main conflicts are about when you create something at implementation side.
Okay.
When you want to add an attribute, add a method, you have a conflict because it is hard to automatically define what is the feature related with this change. But when you just update something, the version already exists with the feature. So conflict is is about creation of object in the notation side.
Yes, again. Yeah.
No more questions?
Just a little one, because when you actually use this, you start from the model and you generate the classes, or you go the other way around also, or you do the mixture, or how does it work?
I start from the model because I start from the feature model, in fact. So first you define the feature model, what I want my multi-platform software, and what is specific for Windows, for example, what is specific for Android, so you start from model, and you start to implement your feature with model, and you can iterate on your model and create some first visualization for simulation, just to debug, to show how it's work, it's a good way to go or not, and then you can continue by iteration, but you start from model.
And then you actually feel them, then once you generate the classes, you generate them, you go and write the code for get the real behavior.
Sorry?
Because you generate methods, but those methods, what is the behavior of those methods? So you have to go to the code side and write them.
Yes. In fact, you don't have methods in Pharo class. You are just method proxy installed in the dictionary instead of compiling methods. And the code can be attached directly on models, on method models.
Okay. Well, maybe you can give me them all.